Page 4 of functions addendum. The modulus function, starting on page 73, is called the modulus, or the absolute value of a real number, which is the distance from 0 on the number line to a number. We write it as two vertical lines like that. Okay? Regardless of whether x is positive on the right of the number line or x is negative on the left of 0 on the number line, the modulus is a positive number. Algebraic definition of modulus. So, when x is greater than or equal to 0, the modulus does nothing. It just returns x. If x is negative, if it's less than 0, then it takes the opposite of whatever x is. It's not a negative number. Negative x means that if x is if x is like negative 3, then it's the opposite of negative 3, meaning positive 3. The graph of modulus looks kind of like a V, because here it's just the identity function, right? 1, 1, 2, 2, 3, 3, 4, 4. But when you get on the left side, you got negative 1 modulus would be positive 1, negative 2 modulus would be positive 2, etc. So you would have a reflection, and you would have basically a V at 45-degree angles. Of course, its vertex is centered on the origin. If a equals negative 2, b equals 3, and c equals negative 4, find the value of the following moduluses. So the modulus of a would be positive 2. The modulus of c would be 3 times 3. I'm saying 2 times 3, because the modulus of negative 2, which is a, is 2, and the modulus of b, which is 3, is just 3. E, a minus b modulus. So that would be negative 2 minus 3 modulus. So first you would do what's inside the modulus functions. It's kind of like parentheses. So you'd have negative 5 modulus. It would be positive 5. G, a plus b modulus. So that would be negative 2 plus 3 modulus, which would be 3 minus 2 is 1. So the modulus of positive 1, which is just 1. I, modulus of a squared. So we got modulus of negative 2 squared would be positive 2 squared, which is equal to 4. C divided by a, which is negative 4 divided by negative 2 modulus. That would be equal to 4 over 2, which is equal to modulus of 2, which is 2. If x equals negative 3, find the value of 5 minus x modulus. So that would be 5 minus a negative 3, which would be equal to modulus 5 plus 3, which is 8. It's 8. C, 2x plus 1 divided by 1 minus x modulus. So first we're going to do what's inside the modulus function. We're going to put 2 times negative 3 plus 1, like that. And then on the bottom we're going to have 1 minus negative 3. So on the top it will be negative 6 plus 1, which is negative 5. On the bottom, we're going to have 1 minus negative 3, which is 1 plus 3, or 4. So the modulus of that would be 5/4. 3a, we're going to complete this table. So, 6, if a is positive 6 and b is positive 2, then the modulus of each one added is going to be 8. If we have 6 and negative 2, then the modulus of b would be positive 2, and then 6 plus 2 would also be 8. if negative 6 was negative 6 was a negative number and 2 was positive, same thing. Negative 6 would become positive 6, so they would add together an 8 also. If both a and b are negative, negative 6 and negative 2, you take the modulus of each one, it would be 6 plus 2, which is also 8. Okay, now modulus of 6 minus the modulus of 2 is going to be 4. Modulus of 6 minus the modulus of negative 2 would also be 6 minus 2 is 4. Modulus of negative 6 minus the modulus of 2 is 6 minus 2 is 4. Modulus of negative 6 minus the modulus of negative 2 is also 6 minus 2, which is also 4. Here we are going to take 6, add it to 2, we'll get 8, and then we'll take the modulus of that, which is also 8. 6 minus 2, which would be 4, modulus would also be 4. Negative 6 plus 2 would be negative 4, and the modulus of that would be 4. Negative 6 minus 2 would be negative 8, and the modulus of that would be 8. 6 minus 2 would be 4, and the modulus of that would be 4. 6 minus a negative 2 would be 6 plus 2, which would be 8. Modulus would be 8. Negative 6 minus 2 is negative 8, and the modulus of negative 8 would be 8. And negative 6 minus a negative 2 is negative 6 plus 2, which would be negative 4. Modulus of negative 4 is 4. 2 minus 6 is negative 4. Modulus is 4. Negative 2 minus 6 is negative 8. Modulus is positive 8. 2 minus a negative 6 is 2 plus 6, which is 8. And the modulus is 8. Negative 2 minus a negative 6 is negative 2 plus 6, which is 4. Absolute value is 4. Okay. B. Are the following true or false for all real values of a and b? Let's look at 3a and see if this helps us. So is a absolute value of a plus b equal to the absolute value of a plus the absolute value of b? So let's see where they match. We're talking about this and this. So do these always match? No, look at that. This is 4, this is 8. They don't always match. So the answer here is, are the following true or false for all real values? So false. They're not false for all real values. They're false for some real values. Okay, so sometimes false. Okay. 2, a minus b and a minus b separately. Let's see. A minus b and that. And no, there's, look, a couple cases where they're different, right? So, sometimes false. All right. Now we're going to complete the 4a table. So, we're doing products. So 6 times 2 modulus would be positive 12. 6 times negative 2 is negative 12. The modulus of that is positive 12 also. Negative 6 times 2, which is negative 12, modulus is 12. Negative 6 times negative 2 is positive 12, modulus of that is 12. Modulus of 6 times the modulus of 2 is 12. Modulus of 6 times the modulus of negative 2, which would be positive 2, is also 12. Negative 6 modulus is positive 6 times 2 modulus is 12. Negative 6 modulus times negative 2 modulus, 6 times 12 is 12. A divided by b modulus would be 6 divided by 2 is 3. Modulus is 3. 6 divided by negative 2 is negative 3, and the modulus of that is 3. Negative 6 divided by 2 is negative 3, and the modulus of that is 3. Negative 6 divided by negative 2 is positive 3. The modulus of that is 3. Modulus of 6 divided by the modulus of 2 is 3 also. Modulus of 6 divided by the modulus of negative 2, which would be positive 2, is also 3. Modulus of negative 6 is 6. Modulus of 2 is 2. It's 3. Modulus of negative 6 divided by the modulus of negative 2 is positive 6 divided by positive 2, which is 3. Interesting. Okay. Use the fact that absolute value of x equals the square root of x squared to prove that for all real values of a and b, AB, absolute value of AB is equal to the absolute value of A times the absolute value of B. Okay, so we can see that's true at least for a few of these values, right? So like AB equals A times B, at least for the combination 2, 6, making them positive and negative, it's true. So let's try to prove it using this. Okay, so instead of putting modulus, we're going to substitute square root of x squared for each one. So for this one, we'll put square root of ab squared equals the square root of a squared times the square root of b squared. So let's let's combine. Let's expand this. So AB quantity squared is actually equal to a squared b squared. And then on the right side, we're going to multiply these two square roots together, and we'll also get a squared b squared into the root. And look, we've done it. Okay? For number 2, we'll do something similar. So we'll have absolute value a divided by b. So we're going to instead put square root of a divided by b squared equals square root of a squared divided by square root of b squared. And on the left side, let me fix that terrible equal sign. Left side is going to be a squared divided by b squared. And then the right side is going to be, well, let's combine the a squared and b squared because we can do that. Everything under the same root sign. And we ended up with the same thing. Okay? And that was page 4.